Hi and welcome to this video for the BTEC Applied Science Level 3. What we'll be doing here is looking at Unit 2, Assignment 1 and talking you through what you should be including within there in order to try and get a decent mark for this. So, Unit 2, Assignment 1. Right, now what I would always do is use the specifications when you're doing your assignment. Don't just rely on the brief itself. Sometimes it's a little bit vague on what you need to actually include. The specifications available online or it will be on your virtual learning environment, should be easily accessible. If not, just ask your teacher. And teachers will be using this and likewise external verifiers as well in order to make sure that you've ticked off everything that's required for the pass merit distinction part of your assignment. So I'm going to be breaking it down within them, what you'll need to actually include. So first off, within this assignment, we've got two pass criteria, we've got a merit criteria, and we've got a distinction criteria. So it's fairly obvious for the distinction and merit what they line up with, but I'll try and pick out the pass and merit bit for you as well. So first off, for the pass criteria, learners will follow instructions, safely undertake titration and colorimetry, may need to refer frequently, so you may need to ask for a little bit of help every now and again for that, but perform correctly to obtain reliable and valid outcomes. So you should be getting somewhere close to what the teacher knows is the unknown result for them. So P1 is this bit in here. As P1 on your brief says, prepare and standardize solutions for titration and colorimetry. So there will be a little bit of calculation involved within that, but generally you should be making up your solution for the titration plus colorimetry. So the standard solution initially, when you're asked to sort of make up a 0.1 mole per decimeter cube solution, 250 cubic centimeters of it. And likewise for the colorimetry, where you're making up the calibration curve and then carrying out the practical, that would be your P1. So generally that should be fairly easy to obtain. There's also a little bit in here that I would typically tie in with P1, where you'll be doing some calibration initially first. And yeah, that's more or less just following instructions that you'll be given. No real need to worry about that as long as you've followed them. P1, more or less do the practicals and have your solutions made up. Now this bit in here, carry out the calculations of concentration afterwards. This is going to be your P2. So P2, once you've actually done the titrations, you'll be asked to work out the concentration of the unknown solutions. And likewise with colorimetry, the concentration of the unknowns there, where you will have plotted your calibration curves and read off the absorbance and down to the concentration to figure out that. So P2, got your titration calcs, your colorimetry calibration curve, plus your unknown concentration. So those are your pass criteria. Should be able to get those done within class most of the time. Now, merit. So merit learners will undertake quantitative analytic procedures, minimal supervision. Key thing there, you should be able to do this experiment without much help. So if you are constantly needing to ask your teacher, if you are constantly seen to be asking your classmate, or if you're actually doing things dangerous and your teacher needs to intervene, you will not get the merit criteria. So for things like this, obviously just keep an eye on to when you're filling up the burette. You've got a funnel in the top. When you're pouring the chemicals in from a beaker with it, then you're at sort of head height for that. And you're not sort of holding the beaker well above your head, in which case it could spill down onto you and obviously is unsafe. And you should have safety glasses on at all times. So as we can see here, with consideration for health and safety. So PPE is very important. You should always be wearing safety glasses and lab coat as well. That is my attempt at a lab coat. Skill and fluency, calibrating pipettes. Yeah, as long as you followed the instructions previously there. Measuring volumes. So you should be seeing the teacher will likely ask you to read off the burette. Remember 2dp. And it should always end in either a 0 or a 5. So e.g. burette reading should always look something like that. If you are recording a table of results where you don't have them, then you will be penalised. Too many of them, you'll drop this. So fully prepared in terms of equipment, reference material, consumables before each step. So generally, there's not any extra work to do for the merit. It's more or less just, have you carried out the practicals that you've done here, the titration and the colorimetry, well? And again, just recorded your results well. Performed to a high degree of accuracy and precision to obtain reliable and valid outcomes. Students will not get the exact perfect result for this, especially since you'll be doing it early in the year, but the idea is you should be reasonably close. So for example, if the true concentration was 0.05 moles per decimeter cubed, and you were getting, say, 0.04 at the end of it for your calculation, I'd say that's pretty good. If you're getting 0.01, then you're quite a bit off. You've clearly done something wrong within the practical. Now, distinction. Learners will interpret outcomes of their quantitative analytical procedures and techniques, make sound judgments on the accuracy of them. So what you want to be doing up here are some equipment error calculations. And some experimental error calculations. You want to be showing me, for example, if you did get 0.04 as a percentage, how good is that for how you carried out the practical? So I'm running out of space here for showing the calculations for that, but I'll be doing some other videos with it. And then you can make a comment on that percentage value that you've got. Is it good or not? Compare it to your classmates. Get a few of their results, say whether or not you've done it better or worse than them. So they will place the accuracy of their results in the context of those obtained by other learners in a meaningful and quantitative way. So grab a few of them, or what you can ask as well is for the teacher to give you the, like this, the true value. You'll need the true value of actually for doing the experimental error on your own. So 2 ways to do that for meeting this top part. I would say do both of them. Get the true result, do the experimental error that you've got, and the number that you've got. Say if you got 0.04 and your classmates were getting 0.29 and things like that, clearly your number is very good. It is much closer to the true one than your classmates, and you can make a comment on that. Now, develop a strong rationale for suggestions made to improve the accuracy and precision. First off, make sure you understand the difference between these two words. So precision is how close your results are to each other. So for example, when you did the titration, were you getting concordant results? Whereas accuracy is how close your result is to the true one at the end. So please understand the difference between them. It's usually pretty good to understand it pictorially. So in terms of a bullseye chart, those are precise, but they are not accurate. They are not near the middle. Whereas this is both accurate and precise. They are near the middle, good accuracy, and they are quite precise. They are close together with each other. So you need to try and improve the titration practical itself and the colorimetry too. So there's various ways that we can do that. For example, the simplest one, more repeats. You could look at, say, using different equipment for the titration rather than relying on your eyes for the color change. You can Google pieces of equipment which can pick up the change at the bottom in terms of the color when the indicator's changed. For colorimetry, it could be something like when you had the little glass cuvette, have you smeared your fingerprints all over it? If you've got fingerprint smears on there, that will stop the light going through and you would get an incorrect reading. So you've got to make sure to hold it on the side where the light is not passing through, and you could use a cloth to wipe the glass clean as well. So for distinction, you're looking at a few for both the titration and the colorimetry to try and improve it. The other final bit here, sound discussion of the inherent hazards and risks associated with the titration procedures and the chemicals. So I mentioned one before. When you're filling up the burette, you should be on eye level with the top of the burette so that you are not pouring chemicals over your head. What else I would do? The chemicals you're using, look up the safety of them. So for example, are they corrosive? If they are, then what steps have you taken to minimize the inherent danger to yourself? Easy one here. Well, we've got some PPE on. We've got safety glasses and we've got lab coats within there. So make sure to do that for each of the chemicals. The hydrochloric acid, the I can't remember off the top of my head what was actually going on. So we've got the copper sulfate as well and the colorimetry. I can't remember what other ones go on the titration, but you can obviously just Google them based on the method sheet that you've been given. So pass, do the practical, making up the solutions. P2, do the calculations. Merit, do the practical well, record your result correctly. Consideration for health and safety, not needing assistance. And then distinction, how do you improve the practical? How good are your results? Do experimental error? Is it above or below the equipment error? Make a comment on that. Get some other student results, compare it to those, and then some safety data on the chemicals that you've been using and the way you've been carrying the practical out, and any appropriate steps that you've done to keep yourself and others around you safe. Thank you.